Hello, I'm Dr. Derek Keats, a former professor of biology, and I'm going to spend a little more time with you on the human endocrine system. This time we're going to look at the hypothalamus, the pituitary gland, and the thyroid, and how they all work together to control important metabolic functions within the body. Let us first look at the hormones that these three components of the endocrine system produce. The hypothalamus produces thyrotropin-releasing hormone, TRH, and somatostatin. One interesting aspect of TRH is that it is only 3 amino acids long, making it a fairly small biomolecule. The pituitary gland produces thyroid-stimulating hormone, or TSH. It also produces follicle-stimulating hormone, luteinizing hormone, prolactin, and growth hormone. We'll come back to these later. The thyroid gland produces thyroxine, also known as T4, and triiodothyronine, also known as T3. These are not the only hormones involved in the central nervous system components of the endocrine system. They're examples, and they're the examples that you need to be familiar with for your grade 12 syllabus, and that's why we're covering them here. They're also among the more important and interesting components. And here we look at the relation among the hormones of the hypothalamus, the pituitary gland, particularly TSH, and the thyroid gland, the T4 and T3 hormones. This triangle is very important to the body's function and is often referred to as the hypothalamic pituitary thyroid axis, or HPT axis for short. Let's start with the hypothalamus. The hypothalamus detects low circulating levels of thyroid hormone, T3 and T4, and responds by releasing thyrotropin-releasing hormone, TRH. The thyrotropin-releasing hormone, TRH, stimulates the pituitary gland to produce TSH, the thyroid-stimulating hormone. Somatostatin, on the other hand, inhibits the pituitary gland from producing TSH. Next, let us look at the pituitary gland. TSH, thyroid-stimulating hormone, is a hormone that stimulates the thyroid gland to produce further hormones. Now to the thyroid. Stimulated by TSH, the thyroid produces thyroxine, T4, and then triiodothyronine, T3, which affects the metabolism of almost every tissue in the body. Let's make a little animation to illustrate this. Take note of our little bar graph down here at the bottom, indicating the rate of metabolism in an imagined tissue. The higher the bar, the higher the metabolism. So the hypothalamus releases TRH, which then acts on the pituitary gland, causing the production of TSH, which in turn stimulates the thyroid to produce T4 and T3. This affects the metabolism of almost every tissue in the body, and as you can see, our little graph has increased. We must also note that there is a negative feedback loop here, in that when T3 and T4 concentrations are low, the production of TSH is increased, and when T3 and T4 concentrations are high, TSH production is decreased. Now let's look at this from another perspective or viewpoint. The hypothalamus produces thyrotropin-releasing hormone, TRH, which acts on the anterior or front part of the pituitary gland. The pituitary gland produces thyroid-stimulating hormone, TSH, which then acts on the thyroid gland. The thyroid gland then produces the thyroid hormones T4 and T3, which are released into the body, where they increase the metabolism and affect growth and development. A negative feedback loop is present in that As the levels of T4 and T3 increase, a signal is sent to the pituitary gland and the hypothalamus, causing levels of TSH to be reduced, thus reducing the production of TSH and keeping the levels in check. It is important that you understand negative feedback, as it forms an important element of the grade 12 syllabus, but more importantly, it is important to understanding your body's function. Can you think of a reason why this negative feedback loop might be important? Let's look at disorders. A failure of any of the components of this relationship can cause the body to malfunction and lead to disorders. For example, hyperthyroidism, or overactive thyroid, happens when the thyroid gland produces and secretes excessive amounts of free thyroid hormones, T3 and T4. One example of hyperthyroidism is Graves' disease. Patients suffer from a number of physical and psychological symptoms, and sometimes they're quite severe. One visible manifestation often seen with Graves' disease is the classic protrusion of the eyes, or protopsis. As you're going to be doing an investigation to research disorders caused by under and oversecretion of at least one hormone, with different learners researching different hormones, we won't cover any more disorders here. We look forward to seeing what you come up with in your investigation. I'm Derek Keats, and this resource is licensed under a Creative Commons Attribution license.